Swayam Prabha. Digital India. Educated India.
Dear students, let us start again with our course on geometric design and the module 2, which is related with cross sectional elements. In our previous interaction, we discussed about the shoulders and we also talked about the median width, which is there for the different conditions of roads or the categorization of the roads. Now, let us move ahead and let us talk that what are the things we are going to discuss today. We are going to continue with the median, we are going to look at the roadway width, the camber, the verges and the parking lanes. So, these are the things we are going to talk in today's interaction. Now, when we look at the median, we talked about the 4-lane and the 6-lane divided systems. In the case of expressways, what are the things which are going to be different is what is being defined here, and that is we are going to discuss here that in terms of the spacing of the median, it should not be less than 5 kilometers. That is the same thing which we have talked for the 6-lane conditions also, but the transition rate here becomes higher, it becomes 1 in 50, which otherwise we have seen that it can be 1 in 15 or 1 in 20. Then on the depressed median side, whatever the carriageway is there, a strip of 0.6 meter were provided previously, now it is 0.75 meters. And the median openings, they shall not be provided on the super elevated sections or within 450 meters of the end of the speed change sections. So, this is one another restriction being defined in the case of expressways. Now, when we look at the recommended width of the median, then for depressed it is minimum 12 meters, but desirably it should be 15 meters. And the reason is if you are going to take one lane on either side, then 3 plus 3.5 plus 3.5, that is 7 meters are going to be there, you are going to left with minimum of 5 meters if you have a depressed median. If it is flush, then there is no possibility of taking the lane, so it is 4.5 meters only. And if there is a requirement that on this flush median some structure has to be accommodated, there is a pair of a overhead structure, then along with the clearances on the side of the columns, that can be an example, then it is 8 meters. So, this is how we are taking the width in the case of expressways. Now, when we have the carriageway, then we have the shoulders, then finally we talked about the medians. Then what all of these are going to constitute together is a roadway width. So, the roadway width is a combination of the carriageway, median, shoulders, or there is any paved surface which is going to be utilized for any specific usage, then that is what is being talked here. So, you can see in the case in the photograph which is being shown, you have a wide space which is going to be a part of a roadway width, because it is going to be utilized for different movements here. Now, when we are looking at this roadway width, then what are the total widths which needs to be provided in the different categories is now we are going to look at. In the case of rural highways, we have the classification as national highway and state highway together, because the specifications are same, and the district roads are divided into 2 categories. So, MDR and ODR are there. Then we have the village roads. So, here for a single lane system and a 2-lane system, the values are being given for plain and rolling terrain as well as the mountainous and steep terrain. What you can see is in the case of national highway and state highway, for a plain and rolling terrain, whether it is a single lane or a 2-lane, we should have a 12 meters wide roadway. But when you are in the mountainous or steep terrain, then it can be 6.25 meters or 8.8 meters respectively for single lane and a 2-lane. But when you are talking about a 2-lane state highway, then in that case on a mountainous and steep terrain, it is again being defined by SP 73 that we should go for 10 meters width, and this 10 meters is exclusive of the parapet or the drains which are going to be provided, and this is one aspect we have discussed previously too. When we talk about the MDR, whether it is a single or two lane, now the width is 9 meters for plain and rolling and 4.75 meters for mountainous and steep. When you are talking about ODR, then again we have a single lane and two lane, which are 7.5 or 9 meters respectively for plain and rolling terrain, but 4.75 meter, and that is for a single lane. We are not providing in the mountainous and steep terrain more lanes for ODR, or if we are talking about VR also, then in that case in the mountainous steep terrain it becomes a minimum of 4 meters as a single lane, but when you are talking about a plain and rolling, then it is 7.5 meters. So, here it means you have a good amount of shoulder being provided on either side of the carriageway. Now, we have some points related to the roadway width. Very first thing is that if you have a state highway and this is not going to be widened to a two lane, it is started with a single lane system, then the width can be restricted to 9 meters only instead of 12 meters. Then the parapet is usually considered as 0.5 meters and the drain is 0.6 meters, and if your road is in the mountainous and steep terrain, then they are exclusive of the width which we have talked. There may be a conditions where the rock is hard in the mountainous and steep terrain and you have to cut that rock so as to create an alignment. In those cases, because of the excessive cutting and the cost involved in that, the width of the roadway can be reduced by 0.4 meters in the case of one lane system and 0.8 meters in the case of two lane system. But when you have a higher altitude and where the snow is a problem, then we may need to increase the width specifically in the lower category of roads, and those lower category of roads like here we are talking about MDR, ODR and VR, in which case the width needs to be increased by 1.5 meters compared to what we have talked previously. If we are going to provide a footpath, because there is a lot of pedestrian activity and the developmental activity on the side of a road, then the footpath should be 1.5 meters wide. Now, another thing is the change in the width of a carriageway, if required, it shall be done at a rate of 1 in 15 to 1 in 20. That is the same rate which we have talked previously also, except for the expressway where we talked the rate as 1 in 50. Now, when you are talking about a road which is being provided in a steep and mountainous terrain, and when we are restricting the width of a road, then there may be a case that there are a number of vehicles which are not being able to overtake the slow moving vehicles. See, a truck is moving in front and the cars are coming at the back, and because of the problem of the performance in terms of engine power and the load being carried, this truck is moving slowly. Now, all of the vehicles at the back has to move slowly and there is going to be a big gap in front of the truck. So, as to take care of that, the passing laybys needs to be provided. Now, what shall be the dimension of the passing lay-by is what is being shown here. It shows that we are going to have flared section which is 3.75 meters wide, which is 30 meters towards the road or the carriageway which we have, and 20 meters on the other side, and that needs to be provided at a rate of 2 to 3 per kilometer depending on the conditions of our terrain, and this will allow the vehicles to cross the another slow moving vehicle. At the same time, there may be a possibility some vehicle has gone down or it is not performing. So, it is a broken vehicle that has to be placed on one side. So, this space can also be utilized for that reason. Now, when you are talking about a plain and rolling terrain and when you are talking about a mountainous and a steep terrain, there always a possibility that there is a river or a nala which needs to be crossed, and depending on the width of that, we are going to have a span of the structure which is being defined as either a bridge or a causeway or a culvert or anything like that. Now, what it says is that if we have the bridges of a span more than 6 meters, then in that case we are going to provide a single lane, then the single lane bridge should be 4.25 meters wide. If it is a 2 lane or more than 2 lane on a bridge, then it should be 3.5 meters per lane, plus an extra width should be provided as 0.5 meters per carriageway. So, this is a case when the span is more than 6 meters. When the span is up to 6 meters, then what? Then in that case, if you are looking at a plain and rolling terrain, then whatever the width which we are going to provide, we consider the width from outside to outside of the parapet wall. So, in the case of plain and rolling terrain we can do that, but in the case of mountainous and steep terrain, as being told before also, we should not consider the width of the parapet wall, and therefore, we are going to take the inner side of the parapet wall so as to consider the widths being provided. And in case of the village roads, the minimum desirable, as we have talked previously, for a single lane is like a 4.25 meter, that has to be there. When we talk about the causeways and the submersible bridges, then in that case the minimum of 7.5 meters should be provided. So, that is another case here. Now, when you have a horizontal alignment, in the case of horizontal alignment, the curvature is going to be there, and when the vehicle moves on that curvature with a high speed, then the centrifugal force will be acting outwards, and this vehicle can be taken outwards while steering if the driver is not alert enough to control the steering. In such conditions or environments, we need to provide a widening on the carriageway, and that widening on the carriageway is dependent on the radius of the curve. So, when we talk about this radius of the curve, what you can see is that this is being talked up to 40 meters and then goes up to 300 meters and more than 300 meters. And for those specific conditions of 40 meters, 41 to 60, 61 to 100, 101 to 300 and more than 300, the values of the widening have been defined as 1.5 meters, 1.2 meters, 0.9 meters, 0.6 meters and nil. The nil when the radius is more than 300 meters. In that case, this widening is not required. When you are talking about a multi-lane highways, then these widenings specifically with a radius of 40 meters is not being defined, or even for 60 meters also it is not going to be defined, because multi-lane highways, they have a higher speeds. They have been designed, if you remember the design speeds that we talked about, 100 kilometers per hour and 80 kilometers per hour. So, when we are designing it for 180 kilometers per hour, then the radius are going to be quite more, and that is the reason that the values which have been defined here in the case of multi-lane highways are 75 meters and onward. Now, when we are looking at the roadway width needs to be provided in an urban area, then what are those things? We are going to talk here about the width which needs to be provided based on the type of traffic which is there, the composition and the vehicles and the various uses exclusively for those particular vehicles. So, based on all of those things within the development of the area, whatever the space is being occupied as being shown here, so that space is what we are talking as a roadway width in the case of urban roads. So, we need to look at who are the users, what are the widths which needs to be provided for those users. Now, another feature is a camber. Now, what is camber? Camber is defined as a cross slope which is given to the surface of the carriageway and which slopes outwards from the center line. So, if I try to make it and I have a center line like this, then I am providing a slope in this direction and I am providing a slope on the other direction. So, this is what is known as a camber. So, my surface is going to be designed in this manner. So, this is my pavement. Now, why we are doing it like this, and what is going to happen if we have a simple this type of a flat surface with a 0% of a slope being provided transverse direction. So, the very first thing which it is trying to do is that whatever the rainfall is there here on this particular surface, so water is coming and that water is going to drain towards the outer side, subjective this slope is being provided, otherwise there is going to be a ponding in the case of these type of pavements. And when the water has gone away and it becomes dry, now we have talked about the friction, we talked about the tire and pavement interaction, and there the friction was discussed, and we also looked at the surface being dry and the surface being wet. So, it is also going to make a difference in terms of the friction which is going to be there. So, that is the reason why we are providing the camber. Now, when we are providing this camber and a slope, then what should be the value of the slope? Now, this value of the slope is going to be decided on the basis of two factors. One is the rainfall intensity and another one is the type of surface of the carriageway. So, if it is a high rainfall intensity, that means the camber should be more steeper. So, it should be something like this, but if it is a low rainfall intensity, then we can work with even this type of a surface. Or if you are talking about a surface, the quality of the surface of the carriageway, whether it is a bituminous road, it is a cement concrete road, it is an earthen road, or it is a gravel road, what exactly it is, that is also going to make a difference, because if it is a good quality of a road, a more smoother a surface, then the water will flow faster. But if it is like a gravel road or a earthen road, the water is going to stay there for a longer time, and that is where more of the slope needs to be provided in those conditions. Now, what are the values of the rainfall intensity which has been used as a cutoff so as to decide whether to provide a steeper slope or a flatter slope? So, in the case of rural highways, this value is being considered as 1500 mm per annum. In the case of expressways, it is being considered as 1000 mm per annum. That means, if the rainfall intensity in an area is 1600 mm per annum and the rural highway is passing through that, we need to provide a steeper slope. And say on an expressway, if it is like 500 mm per annum, so we can go with a flatter slope. So, that is what is going to be the usefulness of these particular data, and this is available from the meteorological departments for any of the area in which the road is being constructed. Now, we can look at the various values of the cross slopes which can be there. As I said, if you are going to a worst type of a surface like an earthen surface or a gravel surface, the slopes has to be more steeper. So, what you can see is 3 to 4% has to be provided if it is an earthen surface. If it is a gravel surface, then 2.5 to 3%. If it is a thin bituminous surfacing, then 2 to 2.5%. If a high bituminous surface or it is a cement concrete surface, then in that case 1.7 to 2%. So, these are the values which are being defined for different categories of roads or the roads which have been constructed by using different type of material. But this can also be defined with respect to the various categories of roads, and that is what we are going to look at further. Before that, one another aspect is that you are draining the water. So, this is your center line, the water is being drained, and this is my carriageway. Now, where this water will go? This water is going to be on the shoulder. So, from this side, now we are going to have a shoulder here. So, when we have this shoulder, so water will get into this particular shoulder. What you need to do is you have to make it a bit more steeper, so that the water flows faster on this surface, and that is what it says is that at least 0.5% more should be provided as a cross slope on the shoulders, and otherwise also the values have been defined. So, what it says is that if it is an earthen surface, then 5%, if it is a gravel surface, then 4%, it is a WBM surface 3%. If you are talking about an unpaved area or the verges which we are going to talk, then 4 to 6%. If you have a paved footpath, then we can work with 3 to 4% only. So, these are the various slopes under different conditions or for the shoulders. Now, in which particular direction we are going to provide these cross slopes? So, if you have a 2-lane system, so this is one lane, this is another lane, what it says is that we are going to provide the slope away from the center line towards the edges. But if it is a divided system, so what you have is a median here like this. So, this is one carriageway and this is another carriageway, then it is being drained away from the median towards the edges. So, on undivided carriageways, slopes outwards from the crown, on divided carriageways, slopes outwards from the edge of the curve. In the hilly areas, it shall be decided on the basis of ease of drainage, issue of erosion on downhill side, super elevation on curve, all of these aspects needs to be taken care of. When we are talking about the curved section, then on the curved section one another element which we are going to design when we look at the alignments is a super elevation, and this super elevation itself is going to take care of the camber, because this is also a sort of raising of the surface with respect to inner and outer edges of the carriageway. So, with respect to one, the another is going to be raised, or sometimes it is going to be done with respect to the center line of the carriageway also. So, we will be discussing about those things when we will take up the super elevation. Now, if you have a 2-lane highway, then there is a IRC guideline separately for the 2-lane highways, which says that we should provide 2.5% for the bituminous surfaces and 2% for the cement concrete surfaces, but here it is not talking about the rainfall intensity. When you are talking about a multi-lane highway like a 4-lane highway or a 6-lane highways, the values are same as 2.5% and 2%, and if the section is curved and it is being placed on an embankment, then the outer side of the curve, the earthen shoulder shall be provided with 0.5% reverse slope, so that the water drains in the shorter direction of flow. What does that mean? So, when you have a curved section, I said that already we have a road which is in super elevation. So, this is a carriageway which is in super elevation, this is my inner edge and this is say my outer edge. Now, there is going to be a shoulder on this side. Now, when we talk about a normal way of a shoulder, then that should have been like this, but that is not a case. What it says is that you provide a shoulder here like this one. So, and then it can be a further in this form. So, at least a 5.5% of a reverse slope, not a slope in the same direction. A reverse slope shall be provided. So, instead of taking the water in this direction from the shoulder, we are taking the water outside from the total system, and that will become shorter direction for the movement. So, this is another important thing which we need to look at. In the case of expressways, again it says 2.5% on the carriageway or the paved shoulder or the flush median or the edge strip, which is 0.75 meters wide, if the rainfall intensity is 1000 mm or more per annum, otherwise 2%. And on an earthen or granular shoulder which is being provided. So, you have two types of shoulders, paved and unpaved. So, we are talking now here the unpaved one, which is having 200 mm thickness, that already we have discussed. So, the slope shall be 1% higher than the values as mentioned above, that means instead of 2.5 and 2 they will become 3.5% and 3% respectively. So, that is how we are going to do it. Now, what is the shape of the camber which can be provided? The first one which you can see is a parabolic, the another one is a straight line, and the third one is a combination of a straight and parabolic. So, when you are looking at this and the rate is being provided as 1 in n. So, what it says is that if this is the center line, I am going outwards in this direction, my width is w. So, when I come up to this point, my distance moved is w by 2. When I was talking about that, when I move n horizontal, then I am going to get 1 vertical. So, when I am moving w by 2 horizontal, then it becomes w by 2n. So, I am going to get this distance. So, if I talk about this level, so my this level difference is going to be w by 2n, and that is what is being shown at the center line of this particular carriageway. So, this w by 2n is known to us whenever there is a rate of 1 in n, but if we are going to have a parabolic, then this will remain same as w by 2n, that height is going to remain the same. But being parabolic, then you are going to talk about y is equals to a x square. Again in this case, with respect to the center line, you are going to move out in x direction and then you are going down in y direction. So, if you are moving x direction, then you are moving up to this point, a distance equals to w by 2 again, and in y direction it is going to be w by 2n. So, if I put these values here, w by 2n is equals to a into x is w by 2. So, it is w by 2 square. So, that will give me the value of a. So, this value of a comes out to be how much? So, this is going to be like 2 divided by n w. Okay, so, we have w square. So, w will come on this side, n remains here, this is 4. So, you are left 2. So, 2. So, 2 divided by n w is the value of a which will be there. So, what equation you are going to get is 2 divided by n w into x square. So, now if you have to find out what is this value of y 1, what is this value of y 2, what is this value of y 3, say you are looking at the distances like half of w by 2, 1 1/4 of W by 2, 1/8 of W by 2. So, accordingly when you put the value of x, you are going to get the value of y, and that is how this parabolic system can be generated. And the same way we can have a parabolic and a straight section. The only thing which we have to identify is this common point at which the height is going to be same, whether we talk about the parabolic or we talk about the straight line. Now, one another thing which is being written is the board, the camber board, what exactly it is. Now, this camber board is nothing but it is going to be a system like this. So, this is a wooden board, and this wooden board has been designed on the basis of this equation y is equals to ax square. So, all of these things, with if we talk about this as a center line, those y's have been defined in that form, all of these y's. So, when the construction is being done actually, then this board is being kept at the top of the surface of this particular carriageway, so as to see that if there is any irregularity in the camber being created, if there is an irregularity, then we have to rectify that, so that we get a good smooth surface on the road. Now, let us look at another element, which is verge. Now, what is verge? Verges are provided between building line and carriageway to accommodate utilities and services, signs, lighting poles, etc. So, this is an extra space which needs to be used so as to provide the all utilities and facilities in that particular width itself, so that whenever you are doing anything on the carriageway, it is not going to create a problem to all those utilities and facilities. Otherwise, if everything is being placed within the carriageway and you dug it, then these facilities are going to be having a problem, because there may be something which get broken or so. Then when it is being provided on the side of the carriageway, then it also allows a proper space for vehicle placement, and it will also allow the development of the full carriageway capacity, because now you are not restricting the things, you have an open space available on that. So, that is going to work in a positive manner towards the capacity of the road or capacity of a lane. The minimum width which needs to be provided is 1 meter, and it is provided with a 5% of the cross fall, and that 5% is going to be when it is turved, but if it is a surface drived then or cobbled, then it is 3%. That means there is a material being provided, so the whole of the water is not going to penetrate within it. So, we can have a flatter system also. In the restricted cases, the full width between the building line and the carriageway, they can be paved. So, that is a additional thing which may happen, and then we are going to embed the things in this one, but that can create a problem later when we are looking at it. So, what you can see is that you have a carriageway here, you have the shoulder which is paved and unpaved, and then there is an space being provided here in which the signs are being located. Here you can see this is another soft way of providing it. So, you have a paved shoulder, and then the unpaved area which is there has been utilized for provision of either this or any other thing which needs to be provided here. So, that is the utility of the verges. Even at when you go underground, you can have the telephone cables, the optical fibers, all of those things, or even the water lines, sewerage lines, those are also the things which can be provided here. Now, another thing which is of importance specifically in the urban areas is the parking lane. Lot of vehicles are there in the urban areas and they are not being utilized continuously, and that is the reason the parking lanes needs to be provided. So, they have to be provided in the busy areas, in the shopping center areas, or the business places, the commercial places, etc. All those areas where lot of movements are going to be there in terms of in and out movement of vehicles, we need to have a parking lane. But when we are looking at this parking lane, whether we can provide it on each and every category, say we are talking about a local street which is already having a very less of the width, can we provide a parking lane on that? We cannot provide it there because it is going to take or consume some space. So, the classification of the road is also going to be an important thing. Now, minimum width of the parking lane as far as possible should be provided as 3 meters, but at an absolute level that can be provided as 2.5 meters. So, this is in between 2.5 meters and 3 meters. Now, during the peak time, there is a lot of traffic and your lanes are not being able to handle the traffic, then during that period we can see as a policy measure that the parking is not being allowed at this point of a time or during this particular hours, and therefore, the additional width which is available in terms of a 3 meters or 2.5 meters can be used as a traffic lane. So, that is an additional thing or utility which comes out of it. Now, when you are talking about the busy conditions and lot of traffic is moving, then it is always better that the vehicles are parked parallel to the curb side. When we say parked parallel, this we are talking with respect to the curb side or the footpath, parallel to the footpath. If and if only the land is available, then we go for an angle parking. So, what means to say is that if this is my curb side and this is a footpath, this is a curb. If it is a busy area, then the vehicles are going to be placed like this. But if the land space is available and we can afford, then we can go with the angled parking like this. So, these are the possibilities. The few of the things have been shown here. What you can see is there is a parking space being provided here. This is a sort of a median which is taking away the other movements on the other side, protecting them. There is a channel being provided so as to drain the water, take the water through that. So, this is one way of doing it. This is very adjacent to the carriageway being provided here. So, this is my parking lane and that is a carriageway being separated by way of a one single line which is continuous in nature. What you can see here is that there is a pedestrian facility. So, I have a footpath here, I have a cycle track, that is another thing being provided, and then this cycle track is being taken away with respect to the parking lane by way of this hatched area which may be not less than 1 meters, and it also allows the opening of the door of your vehicle which is being parked at that location. And then you have a carriageway on the other side. So, those vulnerable users who are pedestrians or cyclists, they have been taken away from the traffic. Here you can see the other type of a design where the parking has been taken very near to the curb line. It is being separated by way of hatched marking with the cycle track lane, and the cycle track lane is just adjacent to the main carriageway. So, this is another way of a design which can be there. So, these are the ways the parking lanes can be provided. So, we close our interaction here and we will be continuing our discussion on the cross sectional elements in our next interaction also. Till then, thank you and bye.